Good afternoon. Welcome to the 10th installment of my Kernighan and Ritchie series. In this series of videos, I read and react to the Kernighan and Ritchie book. If you do not know this book, it's called C Programming Language 2nd edition. The book was published in 1988 and has since been one of the most important resources to learn the C programming language. It was written by the people who actually invented the language, people behind the Unix operating system and people behind the C programming language, because C and Unix share a common ancestry, I could say. They were developed by the same people, and basically there wouldn't be Unix without C, and there wouldn't be C without Unix. And in the previous video, we did some exercises regarding line folding and removing comments from C code. And in this video, I'm afraid we have to face the final boss, which is exercise 124. Write a program to check a C program for rudimentary syntax errors like unbalanced parentheses, brackets, and braces. Don't forget about quotes, both single and double, escape sequences, and comments. This program is hard if you do it in full generality. So I actually went out to search for the C specification to see how comments are defined. And oh boy. So basically I found out one thing, that if you put a backslash as the last character before a new line, then this new line is ignored. And you can, so basically, maybe let me try it like this. Okay. Yes, so let me create a directory. Copy the git ignore from 09 to 10. Copy the make file from 09 to 10, and copy the uncomment program from to video 10. And in here I will show you what it looks like. So basically, yes, this works. So if I put a double slash in the beginning of a line and then put a backslash at the end of the line, then the new line is ignored, and this is treated as a comment as well. And another thing I found is that there are these tokens, so these operators, left bracket, right bracket, left brace, right brace, a pound symbol, and double pound symbol. They can all be substituted for these symbols. So left square bracket can be written as less than and colon less, and this can be written as less than percent less, percent greater than, and even the pound symbol can be substituted for a percent colon. And I didn't find the source, but I think this was related to pre-ASCII encodings, in which on some systems these characters did not exist, but for some reason these existed. So like on an older system, you could just use these if this didn't exist. And I also checked that this still works even with like latest latest Clang and C++ GCC. So you could no, you don't have to do it like this. You can do it like this. So char line, and then we can equals hello world. Okay, and then now we can do it. We can put it here. Okay, so this is very cursed, but it works. So if you thought you knew C syntax, then oh boy, I've just like with everything, we have bad news. So yes, I don't think in my program I'm actually going to implement these syntax quirks, because they're not commonly used in modern C programs. Maybe arguably this one I should probably do, but yeah, maybe I could do it. So anyway, this exercise is probably the most complex we've done up to this point, because we're going to need to introduce a new data structure, and I think we're going to have to introduce a stack. And I've looked at a possible implementation of a stack, and where is one coming from? The book Crafting Interpreters. Yes, this is an amazing book. If you have some time, I totally recommend you read it. It's available for free online, and I think it was somewhere here. No, okay, next chapter. There is an implementation of a stack. Where was it? Oh boy. Was it here? Maybe here. No. Here. No stack. The value stack manipulator. Yes, it's here. Okay. So this is where I found my inspiration for this stack. So basically what the stack does is okay, we define an let me make it bigger. We define an array with which is stack allocated, because we define a maximum size, and we define a pointer to the pointer just behind the last value on the stack. And we do it this way because if we use the pointer of the next value on the stack, then an empty stack would point to the first element, which is more convenient than having to point to an element before the beginning. And the stack, as you know, a stack, as many of you probably know, a stack is first in, first out data structure, which means that the first value you put on it will be the first value you get. So I would start by okay, let me just start doing this exercise, and then you can do it one step at a time and then look at what can be done. So I think we could just call it lint and start with including stdio, and let me define a syntax as data structure for our stack. So we should type the struct stack, and in here we're going to need a token thing, right? So my idea is that if we have to check for unbalanced parentheses, brackets, and braces, then we need to have, every time we encounter an opening parent, bracket, or brace, we put it on the stack, and when we encounter a closing parent, bracket, or brace, we check if the last value on the stack was the opening pair. And if it wasn't, it means it's a syntax error because we have interleaved types of parentheses, which is a syntax error. Okay, so a token, we are going to make it an enum, and we have token left parent, which is this left parentheses, token right parent equals closing parent, and then bracket will be left square bracket and right square bracket, okay, and brace will be an opening curly brace and a closing curly brace, okay. So, and the stack will be yeah, we can make it maybe 256 is enough for now. So stack tokens or next stack stack max and token stack top, okay. And we are going to have a function to reset the top of a stack. And I know that in I think in my previous videos I mostly used snake case function names. I think I will be using the camel case function names like as the one used in here. Okay, where? Yeah, this could be a static function. Okay. I'm going to define it as in front, and we define it after main. I declare it before main, and we define it after main. So static void reset stack. It probably doesn't really matter if it's static, because in this book in this book you end up writing a lot of different files, and here we just write everything in one file. So this shouldn't really matter. But anyway, this basically says that, oh, we also need to define a global, right? So stack. Okay. And then stack top equals stack. Now the funny part is that this is technically an internal pointer variable. This is a meme where some basically this is an internet meme. The term internal pointer variable comes from some Indian programming tutorial, and this is actually an internal pointer variable, and so we are setting the pointer of stack top to the variable of we're setting this property of stack top to the stack, and since stack is the property stack is a stack allocated array, it's basically a pointer to its beginning, so we can assign it to a different property, which is stack top. This is called internal pointer variable, and this is exactly what we're going to do. We need to set this pointer to the beginning of the stack before we can operate on this pointer. And in the beginning of main, I'm going to call reset stack, and then I think we're going to do a similar thing as in previous videos. So first we basically iterate over each character in the input, and there is a multitude of things that can happen. So if C is a token left brace, or if it's a token right brace, or if it's a token left brace, token left bracket, or token left paren, then we are going to put it on the stack. So push C, okay, break, case token right brace, case token right bracket, or case token right paren. So if we get a token right brace, or token right bracket, or token right paren, then we need to check if the previous token was matching, right? Okay, so let's write a function to pop. No, it's going to be token pop, and so void push token stack stack top equals token stack top plus plus. So what this does is, since the pointer, stack top is the pointer to the value right after the end of a variable, right at the end of the stack, when we dereference the stack top pointer, when you dereference this pointer, you can put something new. You can put a new value in there, and then we just iterate the pointer afterwards. And the analogously, yeah, this is a token. Analogously, if you wait, how does he do it? Pop. Okay, yeah. Okay. Stack top minus minus and return pop stack top. Yeah, we move a pointer back to the actual last value, and then we dereference it, return the value dereferenced by it. And I think in here we should also we should also check for do like a bounce check. So maybe I can define a token error, and that will be -1 or 0. So if stack top equals stack return token error, and yep. So if a stack is empty, we cannot pop. We have to return an empty. Okay, and then we we check the pairs. Okay, so I will want to define a helper function that will tell me if the if two tokens are a pair. So token, and so token matching. So if my token is token right parent, then I return a token left parent. If it's a token right bracket, then I return token right bracket. If it's a token right brace, and I return token left brace. And if it's anything else, we return a token error. Okay. So now we can see can say token equals pop if last equals, if last does not equal matching token for C23, okay. Okay, well, I need to define a variable for it. Last token, the previous. Okay. Okay, so this is a syntax error with unmatched tokens. Okay, so what this is going to do, if we encounter a right curly brace, a right square bracket, or a right paren, we're going to check if we're going to see the last token on this stack. So if it was a right brace, we have to make sure it was a left brace. If it was a right bracket, we need to check that it was a left bracket, and if it was a right paren, we need to check if it was a left paren, right? So yeah, this is very basic, and let me also define a function to just throw an error message. Okay. Okay, we print fatal. We print a message, and we exit, right? What was it? Man exit. Standard C library. Okay, it's in stdlib. We want to exit with a non-zero syntax error, with a non-zero exit code, right? So this is kind of analogous to the log.Fatalf function in Go. I'm not sure if this is according to any conventions. I'm just going to make it up. So it's fatal unmatched okay, wait, can we also make it a fatal F, right? How do I write variadic functions in C? Can I do it? I think I can. I guess I can. Maybe I also need to ask if I should. Right? Right. Well, this works. I don't know. can I do it? vfprintf. Okay, maybe I could do it something like they do it. Okay, so we get an va list args and the va start args error and vfprintf. Yeah, we also should print to standard error and error and args and va and args. So where is this va start defined? It's in stdarg, okay. Okay. Param. Oh boy, I'm not sure if this will work. And I'm going to rename this to Fatalf. Token unmatched token unmatched token like this. Last token to be on this stack to be okay, like this. So C and previous, like so. Oh boy. So let me see if this compiles. Lint. Okay. And let me try and lint like test.c. No. Okay. Let me see if okay, I am going to rename this as obscure syntax.c, and I'm going to define a new file called test.c, and this is just going to be a simple what was it called? A simple hello world thing. You're not going to be compiling this. It's just to test syntax. And okay, and what would happen if I tried to add an unmatched parentheses? Nothing. What if I give it another closing parentheses, right? Yes. So this kind of seems to work because we are we are getting an error for a closing parenthesis, but it was not accompanied by an we have a closing parenthesis, but was not that was not accompanied by an opening parenthesis, right? And so if we see the test file again, we see that this is, of course, this is highlighted by my editor, but it doesn't always have to be. So we already have this working, and I think this is a good place to commit. So this is a video 10. Check unmatched closing tokens. Okay. And okay, so on this stack we're going to have opening delimiters, and for every closing delimiter we check if the stack, if there is a matching delimiter on the stack, right? So we can just if stack is empty, right? If stack top if this stack is empty, is not empty. If it's not empty, we have reached end of file without finding a closing token. So we can save previous equals pop and Fatalf. End of file reached without matching token for matching closing token for token. We want matching token to be okay. You want a matching token for previous, and we need to expand the matching token function because it currently only supports pairs for opening tokens, for closing tokens. So token left brace return token right brace. For token left parent it should return token right parent, and for token left bracket it should return token right bracket. Okay, so now let me compile, and in this file we can I'm going to save it with a syntax error like this. So yes, it correctly says that we have reached the end of file without a matching closing token. Good. And also in Fatalf, I don't want to have to have to write and yeah, basically I'll write a check if there is an I'll check if there is an a new line at the end, right? So size t len equals string length of error, and this returns length of s. If does this include the terminator? Length of a string excluding the terminating null byte. So if error length -1 is not equal to a new line, put char new line and exit. So man lint test.c. Okay, this didn't work. No, if it's not equal to, okay, make lint. Good. Yeah, so now my shell was telling me that the output of our program did not contain a new line. Did not contain a new line, so I wanted to add a new line, so I don't have to get this ugly percent sign at the end. And okay, so this is almost looking good, but we still haven't handled two cases, several cases required by the exercise. So we haven't handled, we didn't handle single and double quotes. We did not handle escape sequences, and we did not handle comments. But yes, they did warn us it's going to be difficult. It's going to be hard, right? Okay, I'm going to commit for now. Handle unmatched opening tokens. So now we can look at uncomment, and we can copy some code. Okay, consume string literal, consume, yeah, we can basically copy all the code. I can quickly walk over this code. So consume string literal is consume string literal is a function we wrote yesterday for the uncomment exercise. So when we encounter a double quote, we have to we do not treat anything inside the string literal as syntax, because we do not treat anything inside those double quotes as syntactic tokens, because for the purposes of parsing code, the for the purposes of parsing code, the what do I want to say? For the purposes of parsing code, a string is an atomic entity, kind of. We treat it as one token. And so we start from a double quote, and if we encounter a backslash, we see if it terminates the literal. We just, if we encounter a backslash and a double quote, we treat it as not terminating the literal. And this implementation also prints the tokens out, and we technically could do it for now just for debugging. So in our main loop, we have to handle this before the actual syntactic tokens. So if it's a double quote, we consume string literal and break. If it's a single quote, we consume a char literal and break. If it's even x char okay, so we cannot pick like this, because if we pick on the next character, okay, so the thing I did in this uncomment program was I was picking at the next character, but if the next character is okay, so I think we have to do something else. We need to see if the previous character was okay. If the previous character was also a slash, then we start a C-style comment. If the last C was okay, so we can see if the last C was also a slash, then we can say that we consume CVP style comment, break, case asterisk, if last C was a slash, then we consume, and this good, okay, consume C style comment, and yes, so if we so we have two variables. One is pointing to the previous character, and one is pointing to the current character. And this way we do not have to peek. So if the previous character was a slash and the current character is an asterisk, it means we are at the beginning of a C style comment. If we are at if the previous character was a slash and the current character is a slash, it means we are at the beginning of a C++ style comment. So one going until the end of a line. And yes. So if we did not, we're going to return here, okay. And we don't have to yes, so consume chars until end of file if you encounter this escape sequence. Continue operation. Success correctly terminated a string literal. And if we did not encounter a string literal, it means it's a... Wait, where do I have this? Oh no, this is a wrong program. Okay. Yes, in the consume string literal, we do not have to put char. Continue consumption on when you encounter this escape sequence. And if it's a correctly terminated string, return, and if it's not, it's a syntax error. We can say string literal meets unterminated string literal meets end of file, or end of line actually. So if C equals a new line, and end of file, right, like this. So this is, we don't have to return after this because it's just going to exit, right? Okay. So let's see if this still handles, so does this handle strings correctly? What if I put an opening brace inside? It's treated as correct syntax. What if I add a square bracket here? Okay, yeah, this is incorrect. And what if I put a like bracket and brace here? It doesn't complain. Does it handle comments? Okay, this is interesting. Oh, this is because we are consuming in the cpp style comment, we were outputting an empty space and a new line, right? Again, yeah, this is also good. So the exit code was 0, so this is treated as correct code. And what if you have closed without opening in here? Also correct. Can we handle multi-line C style comments? Like this. Okay, we are also outputting a line that we shouldn't output, like this. Make lint. Okay, great. So yep. Also we can you should probably do something about this char literal, but I'm not entirely sure how to handle it. So yes, this was quite complicated, I know. Does it wait, does it handle closed? We are here we are going to be at the end of a stack. Does it handle? Okay, it expects the last token in the stack to be something else, right? Matching token for a right brace should be token left brace. So for right bracket it should be token left bracket. Yep. Unmatched token right square bracket, expected the last token on the stack to be left bracket. Okay. Does it work with unclosed curly brace? Yep. Does it work with this? Okay. Does it work with its own source code? Lint.c. Okay, yes, I think this is because of the char literal thing. Consume the char literal. Put char. Okay. Yeah, so it does consider its own source code valid C code. So I know this is very complex, and yeah, this may be very complex if you are not used to writing such amounts of code. So variable. I'll add some comments on the screen so it will be easier to read when you open the source code, right? To store global state, and that would be the stack of opening tokens, and I will rename this to use camel case. Literal. consume char literal, consume cpp style comment, and consume c style comment. So in the main loop, we start by resetting the stack. Also, we should probably also reset last C to be 0 or something. We reset the stack, which means we assign the stack top variable to the internal pointer variable of stack, and then we iterate over each character until the end of file. If we encounter a double quote, we start a string literal. If we encounter a single quote, we start a char literal. And then these are more complex because we need to also know the previous character. But basically, if we encounter an asterisk and the previous character was a slash, it means it's a C-style comment. If we encounter a slash and the previous character was a slash, it means we are going all the way until the end of line. And for left brace, left bracket, or left paren, we push the opening token on the stack. Then for the right brace, bracket, or paren, we check the previous token on the stack, and if it wasn't a pair, then it means it's a syntax error. And we call this function, which is basically mostly inspired by Go's log.Fatalf. Yeah. But without timestamp for now. Okay. Yes, so I was afraid that the exercise will take much longer, but I think for now it is done. And if you have any questions for this code, please let me know in the comments below. If you think this was cursed, then let me know as well. And yep, somebody in the comments has pointed out that I call this series Learn C like it's 1996, and I use modern C. Yes, I guess. But on the other hand, I'm not learning C to use it in 1996. I'm learning C to use it now. The 1996 part was referring to an old textbook. And it probably makes more sense to learn modern C and also know how it was used in 1996. I guess it makes the most sense to know both. And for new projects, just use the modern C. And if you have enjoyed this video, please like and subscribe. this, if enough people like and subscribe, I may even start making some money on it. And if you did not enjoy the video, please let me know why, but please don't dislike it. I'm just a beginning YouTuber. Anyway, thank you for watching and goodbye.